All right. Hey guys. So this is just on page 5 in your packet. We're gonna go over just how to solve it and just want to check in and make sure you're doing it right. So what you're gonna do here for this first one, this is just simplifying. So you're gonna take your numbers and kind of separate them, and then you're gonna take your variables and separate them over here. All right. So we're gonna focus on the numbers first, and then we'll look at the variables. So over here, you're going to take out your greatest common factor. Well, the greatest common factor of 70 and 100 is 10. So I'm going to divide these both by 10. So 70 divided by 10 is going to give me 7. 100 divided by 10 is going to give me 10. So that is what my numbers are going to be. Over here for my variables, we know from our exponent rules, and if you don't know your exponent rules, probably need to do some research. From our exponent rules, we know that if there's a division line and we have the same variable, we can subtract their exponents. So 4 minus this 1, which is there, but you just don't see it, 4 minus 1 is going to give me 3. So I'm going to have a to the third over here. And then b to the third over b to the second is going to be b to the first, because we're going to subtract those exponents, right? So now we're going to put all this together. So our final answer is going to be written as 7 over 10, a to the third, b to the first. And again, you can leave off that little 1, and this will be my answer for that one. Sorry for my handwriting. Just going to apologize. All right, over here, we're going to do the same thing. We're going to separate our numbers, and then we're going to separate our variables. All right, so when we do this, we're going to start with our numbers first. What's my greatest common factor over here? My greatest common factor is 2, because they're both divisible by 2, and that's the biggest one that they're both divisible by. And that's going to give me 7 over 4. So now we're going to look at our variables. Again, we're going to use that whole rule of subtracting their exponents because there's a division line in between them and they're the same base. So 3 minus 5 is going to give me negative 2. Well, we don't like negative exponents, so we're going to make sure that we put that on the bottom to make it positive. Y to the first over y to the first. Well, those cancel out, right? So we don't even have to write anything for that one. These cancel out. Z to the first divided by z to the second. That's going to have me z in the first in the bottom. And now we're going to combine these two. So our final answer is going to be written out as 7 over 4, x to the second, and z to the first. All right, so now we're going to actually start simplifying like functions. You always want to remember with functions, you want to factor first to see if you can cancel something out before you start making it complicated. So for instance, in this denominator, we're going to factor because our numerator is already factored. A lot of people are trying to factor when there's nothing to factor in the top. Unless you have an exponent of 2, you can't factor 2 or greater. So in the bottom, we're going to factor this out. So we're going to do our big X. 3 times negative 4 is going to give me negative 12 in the top, 11 in the bottom. And what two numbers will make that happen? Well, I know factors of 12 that if I add them together, I'll get 11 are 12 and negative 1. Well, now I have to do the box, okay? And the reason why I've got to do the box is because my leading coefficient is bigger than 1. So this will give me 3p to the second. This will give me negative 4 in the bottom. And those two numbers I just found, I'm going to put those inside these boxes that are diagonal and slap a p onto them. So it's giving me 12p and negative 1p. And now I'm going to take the greatest common factors of my rows and columns. So over here, this is going to give me 3p. This will give me negative 1. This will give me p. And this will give me positive 4. So if I rewrote this whole fraction, I'd get p plus 4 over p plus 4 times 3p minus 1. And as you can see, these two things are the same. So we can cancel these out. When we do that, we get 1 over 3p minus 1. But we got to make sure that our domain restriction is taken care of. That means what's in the denominator, we're going to set equal to 0 and solve. So that's going to give me over here 3p minus 1 equals 0. I'm going to add 1 to both sides. Divide by 3 on both sides. Yes. And that's going to give me p cannot equal 1/3. And that needs to be included in our answer because we have a domain restriction here. And what I mean by domain restriction is actually if you graph this, you're going to see that there's like kind of like a little hole, or there's really nothing at p equals 1/3. The graph does not continue. We're going to see that more in this next unit when we start doing graphing. But for right now, we just got to state domain restriction. All right, so on number 4, we're going to factor first. So that's going to give me x minus 5 in the top times x plus 2. And so you could have done your big X method, and you're going to notice that your a times c is negative 10, and your b is negative 3. So what two numbers will make that happen? Negative 5 and 2. That's where I got that from. And then in the bottom, I'm going to have x plus 5 times x minus 5. And again, you could do your big X. You're going to a times c is going to be negative 25, and your b is going to be 0. So what two numbers will make that happen? Negative 5 and positive 5. That's how I got that. So now I'm going to cancel out what I have in common in the top and the bottom, these two. And whatever I'm left with, I'm going to rewrite. And remember, I'm going to state my domain restriction. So I'm going to take this bottom, set it equal to 0, and solve. When I do that, I'm going to get x cannot equal negative 5. All right, just kind of moving on. I'm not really sure why there is not a multiplication symbol right here, but if you want to, you can put that little multiplication symbol there. So the first thing I'm going to do here is I'm going to factor. Okay, so when I'm doing multiplication, I want to go ahead and factor just to see if I can cancel anything out before I start actually multiplying. So when I do that, I'm going to get this, x plus 4 times x minus 4 over, in this denominator, the biggest common factor is 5x. So if I pull it up 5x, this is what I get. Over here, my greatest common factor is also 5x. So if I pull out a 5x over here, that's what I'm going to get. And by pull out, I mean take what you have here and divide by 5x. And the denominator, I'm going to get x plus 1 times x plus 3. And so now I have this hot mess, right? Okay, so I'm going to cancel out things that are in common in the top and the bottom. Now, if there's this multiplication symbol in the middle, then I can do it for both sides. So what I mean by that is x plus 4 is in the top here and in the bottom here. 5x is right here, 5x is right here. X plus 1 is right here, x plus 1 is right here. And whatever I have left over, I'm going to rewrite. So x minus 4 over x plus 3. We're going to set our denominator equal to 0 and solve, which means that x cannot equal 3. All right, so now I'm going to factor this one over here. So in the top, the greatest common factor is going to be x. So that's going to give me 3x minus 2 when I take that out. On the bottom, I'm left over with that 2x. Over here, when I factor this out, I'm going to get x minus 5. Sorry for my handwriting. Don't have enough space. Okay. X minus 5, and this is x plus 4. And I'll rewrite that in just a second. In the denominator, if I take out the greatest common factor, it's going to be 3. So it's going to be x squared minus 2. So now what we're going to do is we're going to cancel out things that are in common. So we have this x right here and this x right here. And that's it. So now we're going to combine all of our stuff together. So 3x minus 2 times x minus 5 times x plus 4. Rewriting everything that's in the top. That's not canceled out. 2 times 3, which is going to give me 6 times x squared minus 2. And one thing you're going to notice on like your tests and quizzes, and sometimes even on the final exam, sometimes your answer will be written out in this factored form, and sometimes it'll be written out like if you multiplied all of this out. It just kind of depends on the test. But I'm not going to sit here and waste time showing you how to multiply. But if you need to, multiply this out. So you would distribute this, and then you would distribute this, combine your like terms, then you would multiply by this x plus 4. But in the denominator, we've got to set our restrictions. So that's going to give us, so if we set this equal to 0, we're going to get plus 12 on both sides, divide by 6. So x squared is going to equal 2. And when we take the square root of that, we're going to get x cannot equal square root of 2, positive or negative. And I'm sorry, my handwriting is terrible, but you get the gist. All right. So now what we're going to do is we're going to take what we just did and apply it to division. So when we do division, we're going to keep, change, flip. And then we're going to factor and cancel out things. And then finally, we're going to multiply. So, for instance, if I keep, change, flip over here, I'm going to get x squared plus x minus 90 all over x squared plus 14x plus 40. I'm going to change that sign to multiplication. And then I'm going to flip what's on the denominator. So that's going to give me, and the numerator and the denominator. Okay. When I factor, I'm going to get x plus 10, x minus 9 over x plus 10, x plus 4 times x plus 4 times x minus 4 over x plus 9. And I'm going to cancel out things that I have in common. So I'm going to cancel out this x plus 4 and this x plus 4. We cancel out these 10s. What I'm left with is x minus 9 times x minus 4 all over x plus 9. We're going to set our domain restriction, so x cannot equal negative 9. You're going to do the same thing over here. And I think really at this point, you get how to factor roughly. If you don't, I'm going to post a video later on about factoring. But that's basically your biggest thing. Also, on a side note, when you factor this stuff, like this part right here, it doesn't have a C term. So that means you're going to take out the greatest common factor between these two terms, and that's going to be x. They both share an x. So when I take it out, it's going to look like this. A lot of you make this mistake where you say a times c is 9, and then you get like x plus 3 times x plus 3. If you know that you're guilty of that, then what I would always do is suggest multiplying it back out to make sure that you get what you started with. So if I multiply this back out, I would get x squared plus 9x. And that's what I started with. All right.